Now, following with the definition of Gauss's law, it involves finding the total flux from an enclosed surface such as a sphere or a cylinder. As you can see from the differential equations of Gauss's law for both electricity and gravitation, they involve the divergence on the left side of their equations. Divergence involves the dispersion of field lines from a source. Gauss's law of electricity best represents this with a positive point charge where the electric field lines are going outward. I can imagine if there's a negative point charge, the field lines will be going inward. Then it will represent a convergence. Gauss's law of gravitation also best represent this, seeing that the field lines are drawing inwardly. And we can look above to see that Gauss's law of gravitation equation has a negative solution. Next, we can follow with the forces involving both electricity and gravitation. We can start with the electrostatic force. We can understand it from Coulomb's law, being the forces between two charges. Next, we have the gravitational force. And we can understand it as the force of gravity between two massive objects. Now we can follow with their fields. First, we can start with the electric field. And this will be force per charge. Now we'll be leaving the derivation with just a point charge. And next, we have the gravitational field. It's denoted by G, but before we can go any further, we got to understand that from the drawing of the Earth showing that the gravitational field lines are going inward, and best represented by the equation, you see that it has a negative solution. The gravitational field has to start with a negative sign, and it'll be force per mass. Now we can make this derivation. Now in the next video, I will continue with the derivation starting with Gauss's law of electricity. However, this will be it. Thank you for whoever's watching.